Now the time has come for the keynote presentations. And I would like to invite our three speakers to join me here at the Presidium. Professor Raul Weiler, Professor Momir Đurović, and Professor Ivo Šlaus. Our first speaker is a name synonymous with advanced thinking on sustainability. He has published widely on this field with the Club of Rome. He is former president of the European chapter of the Club of Rome. Currently, he teaches a unique course on ethics at the Leuven University and has advised the EU on many occasions. Dear colleagues, please welcome Professor Raul Weiler.
Good afternoon, ladies and gentlemen, colleagues. So the initiative to organize meetings, discussions, opportunities about the transformation in social sense and others is a major concern of many people, thinkers and activists. So I try to say some words on with a question mark, is the civilization, our civilization, in danger? Or, as a whole, the entire planet? And so, let me give some names of people who have written about it, and some of you may know them all, by the way, but they're known. Lester Brown from the International, the EPI, Earth Policy Institute, Washington, D.C. Dennis Meadows, of whom I showed two slides, has been one of the co-authors of the famous report of the Club of Rome, The Limits to Growth, 1972. This year we are celebrating the 40th anniversary of the report, which is somewhere in the direction of Tesla, perhaps. James Lovelock, the writer of a hypothesis in the beginning of Gaia, which is absolutely fabulous to my understanding, and is now, evolving to a theory, an accepted theory, at least for parts of it, to the extent. And last, very loved author is Edward Wilson, biologist of Harvard, who has written many books, and there is one I certainly would recommend. And this last chapter, the title of this last chapter is Humanity Suicidal? So apart from that, these are pictures of opinions, of analysis, of observations for many years. In the meantime, since about 20 years, the IPCC is born, is assembling now about 2,000 scientists or even more, and has contributed, to my understanding, in an extraordinary way, the understanding of our planet, of our Earth. So we cannot anymore exclude the thinking that is going on, even when mistakes are made. But mistakes are still human characteristic, I would say. Before starting the reasoning on civilization and the change and transformation of world vision, or to come to another one. The first slide is from Dennis Meadows. He's known and repeats the again, the CO2 concentration in the atmosphere. So where we were, and no, sorry, I wanted to. I wanted to point. Is there a red light? No, a laser point. Sorry. So yes, there it is. So that was for the year 2000. What we're observing now and where we come from. The next slide is also from Dennis Meadows, and said is indicating there. I presume the data are correct. However, one cannot doubt about the data which are accessible to us about energy and fossil energy, is that from a certain point on, the return on investment is slowing down. Good. The freight. I have two other slides from a well-known report from German energy, the great German experiment on renewable. I recommend to read that in the sense that what happens in Germany, or the planning to go to 2050, to be able to produce 80% of the electricity by renewable energy, by renewable sources. This is a significant figure of what is going on. It is a policy figure, of course, so we don't know if this will be maintained along the democratic process, but nevertheless, yeah. The following one is the big, sorry. This one here, the 80% of that evolution would be good. This is Germany, the picture. The next slide, very significant, has been a study made, last published this year, June 2012. And the German one is from 2009 or 2010, so quite recent, is what is going on in the US, or what is going on in the thinking in the Harvard Business School. And so I bring that. What is presented there is what is going on for 23 countries, oil producers, the increasing of the capacity to produce, the increase by much of that. And in total it's about 20%. This represents, that picture represents the investment which is going on to have more fossil resources for energy purposes. Well, there is a text, I leave it to read. So we have there two fantastic opposite pictures of what the future, not so far, 50 years about, can be or will be. The US is the business as usual. Germany, with Europe, but Germany especially as the biggest industrial nation in the EU and Central Europe inclusive, as a vision to deal with the situation, Earth situation, many people think we are. Now, so in fact, when we look, say that our civilization is in danger, or we are looking for a new vision, I go back to 2,000 years ago, which is not so long for the city, I heard, and I visited yesterday, that the Western world, European world, has been based on two premises. First, the human species is above all other. And I had the human species has been created by a creator, and I leave here, don't specify. That's the first one. So the human species can dominate and play master of others. The second one, by the same origin, if I may, or the same roots, is that the Earth's resources are for free. What does it mean? What does it mean, first, the human species? The human species has, in this philosophy, in this world vision, in this approach, taken out of the natural environment. So the nature is away. And there are reasons for, but that's our situation. It has been in that definition, in that vision, the way that we are now, we are still under influence. And the second one is that the resources are for free, and there are also reasons for that. So being the master, so we can do what we want. And at noon, in a discussion with colleagues, so when something is for free, it's very dangerous, unless one accepts that there are limits. And that, okay, we are not so far. But all that will mean that we live in a value system, and that is the essential point, based on these two premises. So, what has been the evolution, and where is my projection? Is that the first we had a theocratic or theocentric world vision in Europe. Maybe afterwards in other places as well, but then which has evolved to an anthropocentric world vision, with inclusion of a number of religious premises, and which has been changed in a long process which started in the period of the Enlightenment, which is unique and characteristic for our Western civilization or culture, that the rational scientific approach has a right to exist independent of any religious doctrines or assumptions. So that means, as I said, I repeat that, so from theocratic, theocentric to anthropocentric, that the value system which has been built is a consequence of the roots of the premises and not the contrary. So, it means that when we think that we, being humankind, that we need to change, we need transformation, we are in a transfer situation, that our value system has to be adapted to the premises we will accept. Which is then the next one, I call it, and the influence of the people I've mentioned and many others in the beginning, is that we have to evolve to the eco-biocentric world vision. That means, in fact, that the human species is not more than another one. Yeah, so Darwin came in the middle of the 19th century, it's not so long ago. That the Earth resources have their limits, and that we have to not the word obey is not good, but to obey the limits imposed, and that refers in some way what IPCC is doing, and that very first slide. So there is another concept which I didn't mention, but you certainly know, the more that the funder, so it's a footprint concept by Matthijs van Kanhagen, who has been honored recently, a couple of weeks ago, that he is saying that today already humankind needs 1.5 Earth. So I know one can discuss the calculation way, I know that. So, but nevertheless, giving the change is important, that we are running somewhere. And I think that, or I state, if you want, that our civilization has roots, basic roots in nature, in the earth, in the ecosphere, in the earth sphere, in Gaia as a total. And Gaia in this context is the integration of the atmosphere with the biosphere and the lithosphere. And Lovelock, one has not to agree with everything that Jim Lovelock has written. However, this is a real vision, and added to that this triumvirate or triangle behaves as a physiological system, auto-regulating according to the system, to the parameters which are changing, and in this case we are changing. So I'm running out of time. Not yet? No? Okay. So this is the first time that happens to me, but anyway. So can we go on? That would be the first question. And in my lectures I said, which was not really accepted by the students, I said, well, even if we discover a lot of fossil energy sources, we may not use them. So I don't know how you feel that. And so if we look at the first picture of the global warming, IPCC, etc., so we should stop to use them. But what do we see in the previous slide is that the investment, US and the very few companies, about 10, I don't know, so rule the world and not the reverse, that they invest. So there is a complete negation of what a number of scientists are thinking and looking for. So a colleague, John, well known probably, Sean Huber from the Potsdam Institute on climate change, on the impact of climate change, in a beautiful article, he said, anyway, what we are now learning and accumulating on knowledge, that on the Earth, which was not there before, certainly not in an integrative way that is happening now, there will be, or we are living, a second Copernican revolution. This is an idea I absolutely find fantastic, in the sense that when there has been something really, really important, but perhaps not measured in that sense, is that the Copernicus changed the world vision, that from geocentric to an heliocentric, but at the same time changed completely the picture of man, of itself, of himself. So, what IPCC is doing, what all the publications are bringing, the knowledge which is coming on, and also the threats which are clear. I didn't mention the threats, but they are known: deforestation, water, energy. So there are many. It's not only global warming, by the way. It's much more. Yeah, the biodiversity is claimed by many as essential for our survival. But anyway, so that the vision. Can we escape to evolve to what I call the eco-biocentric world vision? So I belong to them that we cannot escape. And it's one thing, but it's not sure. And if we try to escape, then in my text I speak about the collapse of societies, of cultures, have happened during the existence of mankind. So this is not new. And there's nobody that can say it will not happen in the future. So that would be silly to say that, in contradiction with the story. So I think I'm coming to the end of my presentation. That the philosophical part is, let us say, maybe what over the heads of the title of the conference, but on cost, etc. So that I am absolutely convinced that if we have to change values, then we have to change the premises that are related to the values. So I'm very pessimistic that economists will find a new economy when they don't change the premises. But, so this is only what I'm thinking, so that economists in prison shouldn't shoot on the pianist. But somewhere there is the logic. And so where to evolve, I don't know, as many others don't know, but still I think that we have to focus on the premises on which our society is built. So I thank you for your attention.
Thank you, Professor Weiler. Our next speaker is one of the great motivators and activists of scientific cooperation in the area of scientific cooperation and energy science. He is recognized as a bridge builder between the research environments in the EU, Central and Eastern Europe, and the Commonwealth of Independent States. His specialty is energy and high energy physics. He is not only president of the Montenegrin Academy of Science, but also a member of the Club of Rome, European Academy of Science, and World Academy of Arts and Sciences. Dear colleagues, Professor Momir Đurović.
Thank you, Mr. Chairman. I believe you don't mind if I speak from here, since I want to see what I'm showing to the audience. Distinguished participants of the conference, the organizer, thank you for inviting me to say a few words on the very hot topic. A friend of mine, Gilbert File, knew that I spent most of my life in energy, so he asked me to speak on the very intriguing title, Energy versus Power. You can talk on different things when you think on energy versus power, from the physics point of view, from a humanistic point of view, from many other points of view. It's not working. No, I'm pressing the right one. So, this one. No, okay, sorry. So I'm not going to talk to you on the definition of what's work, what's energy, what's power from the point of physics. That's for students. That's what we do, lecturing to the students. Or to talk on the definitions, what's work, what's power, what's energy, and so on, so on. Or to talk to you on the forms on the energy. I want just to talk to you on the problems which we have with energy today in this civilization. The question with the energy is shown really on the bottom illustration. It is amusing how energy has been used in the only last few centuries by a human being. And that is what is producing the most of the problem today for this civilization. Generally speaking, if you look to the ages, growth of population and growth of the use of the energy, world consumption, then it is easy to recognize that the gradient of energy consumption is higher than a gradient of increase of the population. So we know definitely that the major problem today is the energy, and the energy is treated in different ways today. Recently I read even that the main cause of nationalism is the energy. You can define problems of energy in any way. You have to distinguish different terms concerning energy. Primary energy use in the world looks as it is shown here, and as Mahatma Gandhi said, that the world has enough for everything's need, but not for every man's greed. That's very nicely shown by the consumption of the primary energy throughout the world. I have to go fast with the slide. You can have it if you want later on in flash. The problem is that 20% of the world population of industrial countries uses 80% of the world energy. And that's what is the really, this figure 10 to the 6th. If you consider growth of average energy consumption per capita, taking in account increase of population, increase of energy consumption, then you can end in the last millennium that the rise of energy consumption has risen roughly to the 10 to the 6th. And this is nicely shown what we have today by the Human Development Index, energy consumption, kilowatt hour per person per capita. And the problem we have today is to push countries on the right-hand side to the left-hand side, to push countries from the left-hand side to the right-hand side, and then all of them to push down. And that is a problem we have to face and we have to solve. Today we use roughly 30 to 40 terawatts of energy, and 2050 that figure is going to at least double or even triple, and that is something we have to face in all mainstream, especially economic. I'm not going to say that. That is what is going to happen. If we want to satisfy in the next 2 decades minimum needs of energy for growing population, that is between 200 and 300 gigawatt of energy in new generating capacities. If you know that generating capacities have to be replaced, then that figure comes probably to the double or even triple size. What that means, it is easy to speak on energy, on everything, but you have to know, and probably to get astonished, when you know that 1 gigawatt of electrical power, which we use the most, is equivalent to 3 million tons of coal per year. It is equivalent 20 kilometers square of solar cells, today's energy efficiency and technology. 200 square kilometers of windmills, 2,000 kilometers square of fast-growing trees, and so on, coming to 3 tons per year of helium-3 to supply, for example, China only today. So that is something what we have to face and what we have to fight. If we want to reach in developing countries level of energy consumption which is now in USA or even in Europe, which is roughly 45% of USA consumption, then it is going to be in 2100 year factor 6 of increase in energy. In China and India it is going to be even worse. So energy consumption is obvious why it is increasing. It is increasing because of economic development, especially in developing countries, and because of the growth of population. And if we want to satisfy 10 billion people with elementary needs of energy, that is equivalent of 900 million barrels of oil per year. Astonishing figures. So how we can solve the problem? The only possible way to solve the problem is on the Earth's energy budget. That's energy from the sun and chemical energy in the soil. There is no any other solution at the moment. We can't import steel from other bodies from universally. Not only planets, from the moon. Moon is full of thorium. From the moon, moon is not planet. So we don't have technology in this field to be efficient. So we have solved this problem using sun and using coal and nuclear. We get from the sun roughly 100,000 terawatt from sun, using today's, that's distribution in the water level and so on, using today's technology, for example in photovoltaic, roughly from 10 to 18% most. That's only 0.23% of the Earth's surface. Or using, for example, biomass, 1% efficiency, it's only 4.6% of Earth's surface. So one would say, very easy, no problem. Both figures together are less than American army bases on the planet are placed. So you say, no problem, we can solve it easy. How we are going to solve it are different scenarios. This is probably the most common stress. That's from the Institute in Vienna. our guy Ticino and others, but that's another story. But the problem is how we can use the primary energy as a useful energy. And as you know, we have heat, electricity, and mechanical energy as a useful, and primary energy, nuclear, chemical, and so on. So, I don't know, can you read this? But this table shows you how we can use primary energy. In fact, what percentage of efficiency is implied in transformation of primary energy to useful. Probably it is better see here, for example, electricity, which is used the most. It is only 40% efficiency. We say electricity is 98%. It is in generators, but from the primary energy to then it's only 40%. And that is what is producing a number of problems. Very well known today, that's the house gases effect. I'm not going to talk on that. This is a very nice illustration. Human activity, Anthropocene, what produces CO2 and NXO and CHX, and then produces climate change and produces problems, diseases, and different changes in our atmosphere. Basically, we ended up now, I mean, it is hard to say, but many scientists say that we are now emitting twice as CO2 as planet can integrate. So this is just to show you, since we belong, I don't have a pointer, somewhere there, you see. We don't really talk on the, I would say, weather change, probably better than climate change. But you can see that in the area where Croatia, Montenegro, and former Yugoslav countries are, temperature has risen in this period 0.8 centigrade. So that is true. I am not certain that what I said earlier, that we generate twice CO2, which Earth planet can integrate. See, that is some theoretical model, but this is a measurement. I'm not going to talk on different things. I'm just going to say how we can solve the problem. We can solve the problem producing energy, as we say, available, affordable, accessible, and lately, AC stated in the document sustainable. What it means, that is also a set of the problems you saw with availability, reliability, quality of energy, that's mixed energy, accessibility, this environmental impact, economic price, and so on. Sustainability means to provide sustainable development. So that's easy strategy. And how we do that? You see, if we carry on with business as usual scenario, that's 2% economic growth, then investment in the next period is going to be US 35 to 50 trillion dollars. I'm using figure never known in any investment in the history or in the future. And that is something what bothers all of us. That's only for another 50 years. So we have to think how to avoid that figure. Since we don't have, the planet doesn't have, human race doesn't have that capacity to put such money in the energy sector. So we have to really think of maximizing energy efficiency and minimizing energy use and to developing new sources of clean energy. And there are many scenarios around. You can find tens and tens of scenarios. All of them you can group after the time we live in two groups, red and green. Basically, red are probably better shown probably here on this one. That's you see, if we carry on with technical expansion, increasing our technology, then we are going to end up no one knows where. If we are somehow sustain our technological development, then it is going to somehow be available for the future. And if we just reduce our use of today's technology, then new technology, then we can end up, you can see here, the top curve is available energy sources. We can go only up to that. So definitely the solution is, regardless, Fukushima and everything was happening, nuclear power and renewable energy sources. That's another topic, and I'm not going to talk in brief. What we have to do, I had the privilege to be one of the people who signed 2 years back advert in Economist, asking for a new figure of CO2, 380, instead of 550, which was earlier regarded as a sustainable percentage of CO2 in atmosphere. Definitely we now think of 380, and whatever what we do, our knowledge says we have to stabilize CO2 to 380. But another problem is, this as far as energy is concerned, but to provide energy, we need power, not in the physical, in how physicist says. I really wonder how my granddaughter and her generation is going to help us to solve energy problems. And what is the power, human power, which can start doing that? We all know that human brain, although that's only 2.5% of body, is the main human power. I'm not going to go into it. And if we compare how human brain and human power has developed in the history biologically and how it has been developed technologically, then we end up really, you could do some analogy, we end up with human being, biological human being, and you end up with an artificial robot, intelligent being. So the question is, can human being, as it is biologically designed, can help us to solve energy problems and other problems which are related to energy, or do we have to go to the artificial intelligence and to some androids? Those are the problems in the universe. You know that the basic problem is the memory. Our brain doesn't have capacity which is needed as to tackle problems in universe. We usually say that complexity of the nature and complexity of human being is different. That complexity of human being has to be increased to tackle complexity of universe of our planet. So that's just to show that we have different reaction in nature, and that we have to think on femtoseconds and working in the real time faster than our brain does now. This is just to show what has happened in the history, not going to that. But technological evolution is really evolution of the power. I know that many people, especially people from social sciences, don't appreciate it, but that's right. Technology is a power, and it is going to be even more power. So what we can expect from the science to bring to the technology in 21st century and further, such to increase our complexity and to increase and reduce our energy problems. In my view, the major problems which we have to fight and where we have to go is to go to minimize, to miniaturize all things we do. As I will show, that's definitely related to the memory problems, and another is integration. That's systems or interdisciplinary. As far as the miniaturization is concerned, then we mainly quote the Moore's law. And it is questioned when the Moore's law is going to end. Some people say 2020, some people say 2200. But it is going somehow to end. And it is going to increase our artificial intelligence. Probably. I'm not saying that. This is what we still have now. You see, this is the size of the Intel atom, which has 47 million transistors. You see, rise beams. That's Moore's law. Putting more and more memory in smaller and smaller places. That's different cases of miniaturization, which we have even now. And another problem is cognitive research, different source of cognitive research regarding mainly our brain. Not only interaction of the brain, signaling, but diseases too. And there are different fields which we have to tackle, such that we have really to think, is exponential growth of knowledge limited with the human brain? I personally don't think people think it is. I know that many people should say this is nasty, but I personally do think that our memory has limitation, biological limitation. Up to now, it's not possible to increase it naturally. By biology, it is possible to increase it only artificially, and we need that, since we have to tackle many different problems, which are we not able to tackle today as a human being, which we think is the most efficient. So really, we need to organize science completely different. There are many things I stated here. You know, everything is a fashionable in the life, science is a fashionable too. So we have to change many fashions in the science. The major one is that we have to design science for evolution, not for market, what is the case today. Many other things are here stated too. And to make a map of science which is interactive. You can see here there are fields of interaction of different topics in science which we still haven't discovered. There's a huge free space in this diagram where interaction of different topics in science are going to happen and to bring us new solutions. And that is how we are going to solve energy problems. This is just Michelangelo's pictures, which he drew a long time ago. And thank you for your attention.
Thank you, Professor Đurović. The speaker that concludes our opening session needs no special introduction. President of the World Academy of Art and Science and President of its Southeast European Division, member of the Board of the Club of Rome and member of the Pugwash Council, European Leadership Network member, Dean of the University College for International Affairs and Diplomacy. Ladies and gentlemen, Professor of Physics, Ivo Schlaus.
Dear organizers of the conference, distinguished participants, ladies and gentlemen, I'm very proud and yet humbled to speak to all of you. I'm proud because I think that the title, dealing with energy and dealing with economy, specifically money, is really an essential subject of today and has to be addressed. I'm also very proud that, of course, what the World Academy is doing, and of course you heard two of our distinguished fellows, Momir and Raul, speaking before me, and of course they are experts in these fields of energy and situation. You see that the World Academy is actually addressing both of these questions. And of course it's excellent that the Global Roundtable, and particularly the Forty Foundation and Mr. Haris Yusuf, are also working on this very important question, and we do look forward to continue this work. I'm humbled, of course, because, of course, I'm just a physicist, and you can say, well, though energy, of course, is perfectly all right for a physicist to speak on, but money really it isn't. Let me remind you that, of course, it happened to be one famous, of course, physicist. His name was Sir Isaac Newton, who was actually a very distinguished, I would say, Minister of Finance. Remember, he was the head of the Mint, and he did a number of very interesting things. So physicists do have something, of course, to contribute to this subject. Another reason why I'm, of course, extremely proud is that this conference is happening in my hometown. Maybe most of you don't know, since I don't live in Zagreb. I live mainly around the world and sometime in Zagreb. But I was born in Split and my family was from Split. And this is what makes me, in the jargon of Split, the fetivi, which means the really deeply rooted person from Split. And I'm really very, very happy and honored that all of you came to this town that we who have been born in Split regard in many ways as a very, very special town. And I believe you will have an excellent time here. Okay, now, as I said, money, energy, and economy in general are those, are those things which are important in today's time. We are facing the crisis, which is economic and financial, as has been said before by Raoul. The ecological footprint, which means the overuse and overexploitation and pollution, is of the order of almost 1.5. There is a destruction of and threat to humankind common. The humankind common are air, water, Arctic, ocean, bio and cultural diversities. We are facing with inequalities which are not really compatible with what we want to have. And though, of course, in physics and mathematics, the virtual, the imaginary are some normal things to worry about, in economy is a little bit tricky, and the virtual money is considerably larger than the real one. And of course, while the real one is actually, the real one is 50 trillion euros, the virtual one is actually 10 times bigger. Then there is a question of energy, the energy consumption, and the question of the GDP. They are correlated until the level of 3 tons of oil equivalent per year per capita. But if you would put all of the humankind to reach that level, today obviously this is not, then you would need 2.6 times more than what you have today. And now a very important thing where we are as a humankind, we are actually using some of the energies, as Professor Gurovic has listed, a number of various energies. We have both renewable and non-renewable, fossil, nuclear. We may be actually approaching in another 20 years or so the use of the fusion. But following the classification made by the Russian physicist Kardashev, we still are in the category of the so-called first type of the civilization. He said that the civilization that it uses the energy of the Earth is the level 1 civilization. The one that it uses all of the energies of our galaxy of our solar system is the type 2, and then of course the one that would be using the energy of our entire galaxy would be type 3. Obviously we are far from that. And of course the important point deals with the fact of uncertainty. As a matter of fact, you have heard many times how unhappy we are with the uncertainty. We don't want to live in an uncertain world. On the other hand, all of us who know even a little bit physics know that the basis of the entire world is the Heisenberg uncertainty principle. So of course, when we talk about the uncertainties at this level in the social and economic sciences, things are much, much trickier. Humans are both rational and of course irrational. Not only that this is something that Keynes and leading economists wrote, George Soros wrote a lot about this as well. When we look at the development of the humankind, this is the well-known graphs, which shows, of course, the number of millions of motor vehicles and telecommunications and water use and so so on and so on. And then you see actually the population is one of the things which has increased, but actually much less than anything else. Raoul previously was talking about the question of the impact that has been produced by humans in this age, which is called the Anthropocene, as suggested by Professor Crutzen, also another fellow of the World Academy. In terms of the biodiversity, we have broken the limits. In terms of the nitrogen cycle, we have broken the limit. There is a question, of course, whether we are producing too much of the CO2 and what does it mean. And here, if we have it in numbers, okay, these are the pre-industrial time compared with the current, and you see those in bold indicate those where we have really passed the limits. Okay, now let's address the question of the economy. Is there a free market? And many economists would say that no, really not, because both society and governments in particular interfere with the market and make it not really true free. Free market concept actually assumes, as we have said before, a complete, reliable information for all participants, and that is not certainly true. And of course the question is that how market works. It works in such a case that you should not put an extraordinary amount of money artificially created, and when you look just the data for the UK, just the period from last 50 years, then you see that the money has been much, much bigger. And then of course there are a number of other conditions that have to be realized. And in many ways, when you look now at the crisis, one could say that there are indications of market failures. One is the ecological footprint, the other are the bubbles, the third are the question of the unemployment, and then the inequality. Let me just say that Plato, when he writes, he argues for the difference of 5 to 1 among the income of the richest and the income of the poorest. Morgan, at the turn of the 20th century, was for 20 over 1. Now we have 10,000 or more. Now, of course, it's also frequently said that the technology kills employment. That obviously is not supported. The ILO World of Work report indicates that population increased in this interval of the 50 to 2010. The population increased by 168%, while employment increased even more. Now, concerning the inequalities, there is unfortunately correlation between bad health and social indicators that deteriorate as inequality increases. And then, of course, there is a very important question: how do we measure? We all know that, of course, Kelvin was pointing out that unless you measure and you know what you are measuring, you cannot really sensibly talk about anything. So what is done in economics? And economics is being measured by the gross domestic product. Hazel Henderson actually called that grossly distorted picture, by the way. When it was introduced by Kuznets, when he spoke at the US Congress, he argued that the welfare of the nation cannot be measured by GDP. This was repeated by the first Nobel laureate in economics, Jan Tinbergen. And of course, in one of his last speeches, Bob Kennedy said that GDP is not a good measure. Now, there are a number of other measurements that have been introduced, yet why still we are with the GDP? Because GDP is something that measures quickly. We have it very regularly in short time intervals, and a number of other things where you would like to really take the lead, to take into account other things like deleting war and violence, any kind of that increase in inequality, measure what is the employment, measure the effect of the ecological footprint, and also measure how close one is approaching the knowledge base of society. Yes, one can do it. We have done it also in the World Academy. There are a number of other attempts where one can indeed do these things, but the price to be paid is that indeed you have effects which come, measurements which come a little bit later than as promptly as the GDP. Let me point out, of course, that GDP, as we all know, measures economic activity. GDP of the world is of the order of 50 trillion euros. GDP of the United States is of the order, I believe now, of 15 trillion euros. But there is a recent estimate done within the UN University and the University of Cambridge to measure the real wealth of nations. This came out just recently, and it includes, of course, the human, the natural, and the human-made capital. And when you look this, and you take the data for the 2008, then you see that the United States is not those, whatever it is, as I quoted, around 14, 15 trillions, but is really 117.8 trillion, and the human capital is 75%. For the UK, is actually even more, even for countries which are really very, very rich in natural capital like Saudi Arabia, Brazil, and Russia. Still the human capital actually is at least 20, and as much in Brazil as 62%. So human capital is one of the very, very important things, and this is, of course, health, education, but much more the freedom and the choices that human beings have and the activity of human beings. And as Torres from the ILO said, the narrow focus on fiscal austerity is deepening the job crisis. And here are some estimates. There was an estimate made in '97 in Nature that the measure of the natural capital of the world is about twice as large as the GDP, and now when we measure this real wealth of nation, then we see that it is of the order of the 10 times more than the GDP. So this is something that can really be used. And of course, it has been said by the Nobel laureates on the occasion of the 100th anniversary of the first Nobel Prize. They said, as never before, the future of each one of us depends on the good of all. Now, this is by no means new. This is the famous golden rule contained in all of the major civilizations, all of the major religions. And if you look very carefully, already 100 years ago, actually more than 100 years ago, Darwin emphasized what is meant by the concept of your neighbor, and he pointed out that your neighbor is actually the citizen, anybody on this earth, because we do depend on all of them. Now, of course, we come to another important interplay between the governance and the economy. We have now a global world, but no global governance. We are living in a world which is global and rapidly changing. And this is really for the first time that we are faced with that. There is an interesting book that came recently, just a few months ago, by Asamoah and Robinson, Why Nations Fail. And they do indeed point out that this failure is very intricately linked with the problem in governance, or if you want, as we call it sometimes, politics and so on. Our world is not global when it has to react, when it has to anticipate, stimulate, and generate desirable changes. Then our world becomes fragmented. Then we come, of course, to the subject of money, which is one of the very, very important subjects of this conference. Money, of course, is technology, is a social organization to facilitate communication. In many ways, is actually like language. Okay? Money itself, of course, this paper has no inherent values, but money acquires meaning because it represents the productive capacity of the society. It is very old, as a matter of fact, more than 10,000 years ago, even before the agricultural period. Banks, quote unquote, had the Persians and the Egyptians. Then, of course, the first coins are those done in Lydia, the island of Aegina in Greece. Then it was international banking. And then the fiat money, the money that we have nowadays, has been introduced in 180 BC in China, and then the printed banknotes have been introduced also in China. Psychological capacity to place trust, and let me emphasize this word, trust, in each other, and therefore promote welfare of the society. Money, as anthropological and linguistic research indicates, is even older than trade. Usually we connect it with this. And of course, as the English word pound, which is also the word for money and for weight, it's missing, so is the shekel. Then of course what we have to worry is that in addition to monetized and unmonetized money, there is also a lot of those things which are not easy in principle to monetize. There is no limit of how much money or how many kinds of money can be created. Money evolves constantly to meet new needs. For instance, in the 19th century in the United States, they had different, many different currencies. The refusal of England to assure sterling liquidity was one of the reasons. We had, in the last 40 years, there were major instabilities, financial instabilities. There is a vast unmet human needs confronted to vastly underutilized capacity. People are willing to work, unable to find a job. In the United States, there are 18 million empty homes, and there are 3 million homeless, and one worries why they are still. Today's society has capacity to meet the basic needs of all humans. The fact that it fails, that we need, implies we need better, possibly alternative or even parallel money systems. And now, of course, when we saw in that little movie presented about Tesla AC, alternative current, of course, can be also used as alternative currency. So let me go to the question of the alternative currency. Can be created by an individual, corporation, local, national government. Complementary currencies have been already known for quite some time. One of our distinguished fellows, Bernard Lietard, together with some of his collaborators, one of his collaborators I think is among us, has worked and has recently published within the European chapter of the Club of Rome the book called Money and Sustainability, and it deals precisely with the question of complementary currency. Complementary currency has been put in operation after the First World War, at the time of the Great Depression, and really it eliminated about 25% of unemployment and revived economic growth in a few months. There is in Japan the Furaikipu, there is a local eco money, also in Japan, quite successful. There is an idea of the dual currency. We have been proposing, for instance, that in Greece, rather than the austerity measures, maybe one should try to introduce both drachma and keep the euro. There is a proposal of one world currency put forward by Cooper and previously by Nobel laureate Mandel. There is a question of the interest-free money or interest very close to zero, the so-called neutral money network. These are just a number of these various ideas. What we have now is, of course, the gold standard, which no longer exists, where $1 was put equal to 889 milligrams of gold. But that is not sustainable. Here you see why it is not sustainable, and you see that Keynes was also arguing for that. Of course, as a pro is long history and limits. Con is obvious that it has gold has nothing to do. I'm sorry. As a contrary, that gold has absolutely nothing to do with the standard of living, and then it does sound a little bit stupid to mine the gold and then to stick it back in the vaults. You know, you take it from the earth and then put it back into the vaults. Then, of course, is what we have now, and that is the fiat money, namely governments just simply declares how much money we will have. And then there is the idea of the energy standard, and I hope that this will be something that we will be discussing here. Is interesting that it was Henry Ford that proposed it in 21, not as very clearly. It was Mr. Fuller, by the way, in 69. He was also one of the founders of the World Academy. You could, of course, speak of petrodollars, of X-energy, of eco-dollars. And then, of course, you could define $1 to be equivalent to 17 kilowatts of energy. Namely, to have a dollar, in this case dollar or euro, doesn't matter, backed by a fixed amount of electricity. So maybe over there, one should be putting a new wording, the bearer guarantees to have, 17 or 5 kilowatt hours. Pro, of course, is government's action are rigorously tested daily. There is no storage, but a guaranteed supply. Money and electricity, in this respect, they are both a quantity which would be flowing. Here is an attempt of energy-backed money where they are grading gold, fiat, and energy, and you see in a number of things, the grade for the energy-backed is by far best. There's always AA, in some cases A-, while of course, in case of the fiat money, in many ways you have Ds, and you have also 2 Ds in the case of gold. The point pointed out by Luswait more than 10 years ago is that most of the money we have is the money created by commercial banks to make profit. Now, number of the questions dealing with what is money, the role of money. Obviously, money has a social role, is now fulfilled or not. Does money perform currently its social role? Money versus other social institutions. The effect of money on natural, social, and human capital. It was very common at the time of the fall of the Berlin Wall to speak about the end of history, the end of this, the end of that, and Thomas Grieco Jr. wrote a book on the end of money. Role of money in economic and social development. Can we have a money system allowing not only competition and stimulating competition, but also cooperation? Presently, money is regarded as a scarce resource. Maybe it isn't. What is the purpose of banking? Does banking system perform its real social role? Why does our money system lead to resource misuse? The question, of course, is in which way is the money a source of the financial crisis? And of course, here the question of the seigniorage, and of course, maybe even more basic questions. Money dominance and similarly retirement are recent phenomena. We definitely did not have this dominance of money 300, 400, 500 years ago or 1,000 years ago. Then there is a question of growth, development, and our finite world, as were addressed by my predecessor, Raoul Weiler. Then there is a great divorce that we, the World Academy, addressed in our journal Cadmus, the divorce between finance and economy, and then even greater between economy and the human welfare. And the paradox involving uncertainty and values. Then the question, of course, of the property. I believe it was Saint Bernard who said, it is truly mine, only those things which I gave to others. Now we have to speak about the private, about the sovereign, by sovereign states, and the global commons. In physics, of course, we do have limitations, and we know that, for instance, certain laws, the laws of classical physics, are valid only in certain domains and not elsewhere. Do we have the same story in economy or not? And then, of course, are both socialism and capitalism in a way things which are in a way outmoded. I remember a joke which I heard when I visited Poland at the time when it was still under the communist regime, and the story was, a foreign Western economist comes and asks a Polish economy, how about capitalism? And of course, a Pole replied, capitalism is already on the brink of a disaster. And then he asked, how about the socialism? And the Pole replied, one step ahead as always. So of course what happened is that definitely socialism is not a system that is viable system, but the question is whether the capitalism as we consider it has to be changed. And of course I would say definitely it has to be changed, because we are now living in a world which is totally different from the one which was actually in front of the eyes of Adam Smith when he wrote The Wealth of Nations. But let us also never forget, it was Adam Smith who was not an economist, because at that time there was no economy, he was the founder of economy. Adam Smith was primarily a moral philosopher, and he was concerned with human beings. And for him, economy was to talk about human beings, and though he did not specifically develop the concept of the human capital and everything that goes there, he knew that this is the most important capital that it is. And through the work of Nikola Tesla, through joining the energy and the economy, I think we come very close to fulfilling what I hope was the dream of Adam Smith and also of Nikola Tesla, to really work for a world which would be a world good for human beings. Thank you very much.
Thank you, Professor Schlaus.